Right, what is integration? Integration is the reverse of differentiation. And integration is also sometimes known as antiderivative. And what does antiderivative means? It actually means it's the reverse process of differentiation. And the symbol for integration is written in this way. So how do you represent integrations in the mathematical format? So when I write this symbol, this integral symbol, f of x dx, it means that I'm integrating this function f of x with respect to x. And the answer I get, let's say if you let it be a of x plus c. So what does all this symbol means? This a of x represent the integral of fx. Then on the other hand, f of x is the derivative of a of x. It means that when I differentiate a of x, I would get f of x. But when I integrate f of x, I will get a of x. And what does this constancy represent? This constancy is just an arbitrary constant. What does arbitrary means? It means it's not fixed. It means the constant is not fixed. It can vary. Previous slide, we wrote to integrate off of x with respect to dx. We let the integral be a of x plus c. Right, so there is the arbitrary constant c. And how does this c come from? We're going to show it to you in this slide here. So look at all the examples that we have on the left hand side. We can apply the power law. If you differentiate x squared, you will have 2x. And if you differentiate x squared plus 1, you also get 2x. Because differentiating 1, which is the constant, will give you 0. Likewise, when you differentiate x squared plus 2, you also get 2x. Because differentiating 2 is a constant. So differentiating a constant will give you 0. So if I'm going to represent all this number 1, 2, 3, 4 by a letter A, where A is a constant, then the answer we get will be just 2x. So what we're going to do next is we're going to show you how we can actually derive the formula. The formula to how we go about integrating a function. Let's look at the first example. Right, the next step is I'm going to add the integral sign to both sides. And we mentioned before that it does not make sense just to have the integral sign and then with the function 2x. Does not make sense. Just that when we differentiate a function, we differentiate respect to a variable. Like for example, if you have y equals to something in terms of x, then we're differentiating it, get dy over dx. That means you're differentiating y respect to x. Similarly, when you need to integrate a function, you need to integrate it with respect to the variable that you have in the function. So if your function is 2x, then you're integrating 2x with respect to x to dx, and you write it as this way. So if you're integrating 2t, then it would be dt. Therefore, I would have to bring my dx over to the other side, so that I will end up getting d bracket x squared equals to integration dx, 2x dx. Now, in the earlier slides, we learned that integration is the reverse of differentiation. What does it mean? It means that if I were to show you an example, like if you're walking from point A, this is point A, you walk to point B. Walking from point A to point B, if it's the process of differentiation, then if you walk from B back to A, it's integration, because integration is the reverse of differentiation. Then where do you end up at? You end up at point A, right? So this is what it means by integration is the reverse of differentiation. So therefore, when you differentiate x squared and you integrate it, what you get is just x squared only. I'm going to pull 2 out, because 2 is a constant, and then you can divide by 2 on both sides. You will have half x squared. Alright, so half x squared is the same as half x squared plus 0. Right, so let's look at the second example. Right, so we do the same process as what we have done earlier. We add the integration sign to both sides. Okay, and we shift dx over okay, and likewise when we differentiate x squared plus 1 and you integrate it, what you're getting is just x squared plus 1 right, and we shift the position, just pull out the 2. So the integrations of x dx will be half x squared plus half. Right, what we're going to do next is that I'm going to repeat the process for differentiation of x squared plus a. Okay, a can be any constant, right? So we're going to add the integration sign to both sides. Shift your dx to the right hand side. So differentiation and integration cancel off each other. What is left is only x squared plus a. All right, so you can see that from these examples that I've shown you, right, when you integrate x, you will get half x squared, but there may be a constant. It could be 0. In this case here, if it's 0, that is because you are just differentiating x squared. But if you are differentiating x squared plus 1, then what you're getting is half x squared plus half. And then if you represent all this with the constant a, what you need to get is not just half x squared, but half x squared plus half a. Right, so all this, we're going to represent all this constant, we're going to represent it with the letter c. That's the reason why when we write in integrations of fx dx equals to your integral, there's always a constant plus c behind, and this is called the indefinite integral. This one has another name. It's called the indefinite integral. Let's recap on what we have learned in the previous slide. So this is called an indefinite integral, and the formula to integrate x to the power of n, if you look at it carefully, it's x to the power of n plus 1 over n plus 1. Then how do we get n plus 1? You get it by taking the original power, which is n, the original power, which is n, add to 1. That's how you get n plus 1. And then you divide it by the new power. And because this is the indefinite integral, you have to plus c, as we have also explained it in the previous slide, where c is an arbitrary constant. Okay, it's arbitrary because it is it's not a fixed constant, it varies. We have done is just integrations of like x to the power of 2, x to the power of 3, x to the power of 4. If you have a constant such as like 2x cubed, 1/2 x to the power of 4, how do you integrate it? It's still the method to use is still the same. All you need to do is just have to basically bring the constant a out of your integration sign, and then you just integrate, apply the rule to integrate x to the power n. Right, you just take the power n plus 1 divided by the new power, and then a over 1 would just be a can be written as a over 1, so what you get will be just a, then x to the power n plus 1 over n plus 1 plus a constant c, where c is arbitrary constant. Arbitrary meaning it's not fixed, it's not a fixed constant, it can vary. Let's summarize what we have learned so far. Right, so the integrations of a x to the power n will be ax to the power n plus 1 over the new power n plus 1 plus c. C is arbitrary constant. Alright, here it says that n cannot be equal to -1. Right, are you able to explain why n is not equal to -1? Or if n is equal to -1, what happens? So if n is equal to -1, right, then what we'll be getting will be ax to the power of -1. Alright, and in this case here, what we are integrating is 1 over x. So integrating of 1 over x, right, you cannot apply this rule here. Alright, it is a different rule. It will be related to your logarithmic functions. Okay, so this rule that we are using here, you have to be very, very careful. This rule that we're using here, n cannot be equals to -1. Okay, so this one here, if n is -1, then the integrations of 1 over n is actually ln x. Okay, it's a different story altogether. We'll learn it later on. Right, so what happens if n is equal to 0? If n is equal to 0, then what you're getting will be ax to the power of 0 dx. Okay, and then if you move your a out of your integration sign, what you're getting is the power 0 plus 1 gives you 1 divided by 1. So that gives you ax plus c. C is an arbitrary constant. Alright, let's look at example 2. You're asked to find y if dy dx is given by 3x cubed. So what's the first step you need to do? The first step is to write down dy dx equals to 3x cubed. Second step is to introduce the integration sign to both sides. Okay, third step is to multiply both sides by dx. And remember, since integration is antiderivative, that means when you differentiate y and the values you get, if you integrate it, the integration and the differentiation actually cancel each other. So what you get on the left hand side is only y, and on the right hand side you just extract 3 out and you apply the rules to integrate x to the power 3. Okay, so you can write 3 as 3 over 1, and then x to the power 3, when you integrate it, it's x to the power 4 over 4. Then you multiply the numerator, which you will get 3x to the power 4, multiply the denominator will be 1 times 4 gives you 4. And always remember to add a constant c, because you're actually dealing with indefinite integral. Okay, look at part B. First step for part B is to express 1 over x squared as a negative index, x to the power negative 2, introduce integration sign, multiply by dx on both sides, and then you just carry out the rules to integrate x to the power of negative 2. So negative 2, the power negative 2 plus 1. Negative 2 plus 1 is negative 1, so divide by negative 1. So you get you get minus x to the power negative 1. And then you convert x to the power negative 1 into positive form. There will be negative 1 over x, and always plus a constant c. So would you be able to do part C and part D on your own? Maybe I let you try first. Right, so again, the first step is write down dy dx equals to square root x. Square root x is x to the power half. Okay, can you see that the steps are the same? Introduce integration sign to both sides. Multiply by dx on both sides. And your integration and differentiation cancel each other to get y. Apply the rule to integrate x to the power half. You may have a problem managing x to the power 3 over 2 over 3 over 2. I would encourage you to use a calculator. You just take 1 divided by 1 divided by 3 over 2. Use a calculator, 1 divided by fraction 3 over 2, and that will give you 2/3. Okay, so for part D, likewise, dy over dx equals to 5. Introduce integration sign. Multiply by dx on both sides. Integration, differentiation cancel each other, left only y. And when you integrate 5, you're integrating 5x to the power of 0. Okay? That will give you 5x, and then plus a constant, arbitrary constant c. So far we have actually just done integrations of single terms, like integrate x to the power 3, integrate 2x to the power 4. Right, what happens if you need to integrate multiple terms separated by plus or a negative? What is the rule to use? So I've given you an example, right? Recall that if you want to differentiate x squared plus 3x plus 4, you actually get 2x plus 3. So you actually differentiate it, differentiate x squared first, differentiate 3x, then differentiate 4. Okay, so similarly, right, you can also apply the same method when you want to integrate multiple terms separated by plus or minus. You just have to integrate it term by term. Right, so the example given to you, you integrate ax to the power of n dx, and then you integrate bx to the power of n dx, and so on and so forth. Right, let's look at example 3. What happens if you need to integrate multiple terms separated by plus or minus? So if you look at example A, right, first step, write down dy dx equals to x squared plus 2. The steps are still the same. For example 2, as in example 2, you write down dy dx equals to x squared plus 2, and then you introduce the integration sign to both sides, and then you multiply by the x on both sides, and your differentiation integration sign cancel off each other, giving you only y. Then you apply the rules. In this case here now, what you're doing is that you're integrating x squared dx. Then you integrate 2 dx. So the steps are the same for as in example 2, just that now you have more than one term to manage. So if you look at b, right, you have to look at b. Now remember, the integration is for multiple terms separated by positive or negative. So therefore, in example b, you would have to expand the expression. Just a reminder that 2 can be written as 2x to the power of 0 because x to the power of 0 is 1. So basically 2 times x to the power of 0 is just 2 times 1 gives you 2. Right, so for part B, yes, we need to expand x bracket x plus 3 to give you x squared plus 3x. Right, then introduce integration sign, multiply by dx on both sides, and then you integrate x squared. After that, you integrate 3x. And remember to add a constant c to both to your final answer. For part C, it's a bit challenging. Okay, you will have to separate it into 2 fractions. You have to separate the algebraic fractions into 2 fractions. So it's x squared over x squared minus 1 over x squared. So x squared over x squared actually gives you 1. It's just that 2 divided by 2 is 1, right? 3 divided by 3 is 1. So x squared divided by x squared gives you 1. And here, this one, you write it as a negative index is x to the power of negative 2. Okay, so the next step is what we have been doing so far. Introduce your integration sign, multiply by the x on both sides. Your differentiation and the integration sign, okay, cancel each other. So giving you only y on the left hand side. Okay, when you integrate x, integrating 1, you're actually integrating x to the power of 0, right? So that's how you get 0 plus 1 gives you 1 over 1. That's how you get x. And then likewise, do it for x to the power of negative 2. Now be very careful. I would advise you guys not to skip any step. Okay, put your square bracket there, put the square bracket there, right, divide by the new power, because the square bracket will remind you that you have to be careful because the negative times the negative as indicated there will gives you a positive. Alright, so when you want to do integrations or differentiation or any algebraic questions correctly, it's very important that you pay respect to brackets, pay respect to the sign. Right, so for D, the way to do part D is the same. The skill is the same as in part C. We have to separate this into 2 fractions. Right, so just a recall, square root x is x to the power half. Okay, so how do I get 3 over 2? So I get 3 over 2, I'm applying this rule. If you have forgotten, so x to the power of 2 minus, so it's 2 minus half. That gives you x to the power of 3 over 2. That's how I get it here. Okay, right. So 1 over x to the power half, if you convert to a negative index, is x to the power negative half. That's how I get it here. Okay, so you integrate, introduce the integration sign, multiply by the x on both sides. Differentiation, integration cancel each other, so you can find your y. Okay, right, so there's a 1 there, so you just use a calculator, take 1 divided by 5 over 2, and you'll get 2/5. Okay, likewise also, there's 1 divided by half, you get 2, plus arbitrary constant c. Right, so I've gone through enough examples. Of the video is please do question 1, 2, 3, 5, 6 from exercise 16.1 and check the answers behind the book. to ensure that you have done these questions correctly.